Research Methodology. Chapter 3, Data Collection and Processing. Part 3. Process of Data Analysis, Stages 1 to 4. Stage 1, Problem Definition. The research problem is clearly stated so the analyst knows what kind of data needs to be analyzed and why. Stage 2, Data Collection. Relevant data is gathered from primary or secondary sources using suitable methods like interviews, questionnaires, or records. Stage 3, Data Cleaning. Collected data is checked for errors, missing values, duplicates, and inconsistencies that could affect the quality of analysis. Stage 4, Data Coding. Each response is assigned a numerical or symbolic code so that data can be sorted, grouped, and processed systematically. Process of Data Analysis, Stages 5 to 7. Stage 5, Data Tabulation. Coded data is organized into tables so that patterns, frequencies, and relationships between variables become easy to see. Stage 6, Statistical Analysis. Appropriate statistical tools, such as percentages, averages, correlation, or regression, are applied to the tabulated data. Stage 7, Interpretation and Conclusion. Results of the analysis are interpreted in relation to the research objectives, and final conclusions are drawn from the findings. Processing of data, meaning, and steps. Meaning. Processing of data means converting raw collected data into a form that can be analyzed, interpreted, and used to draw conclusions. Step 1, Checking. Reviewing all collected data to identify and correct errors, omissions, or unclear responses. Step 2, Editing. Examining and correcting data for completeness, consistency, and legibility before coding begins. Step 3, Coding. Assigning numerical or symbolic codes to responses for easy classification and analysis. Step 4, Transcription. Transferring coded data from the original forms onto a data sheet or computer for organized storage. Step 5, Tabulation. Arranging processed data into rows and columns in tables for further statistical analysis. Checking objectives and aspects. Objectives. 1. Ensure completeness. Verify that all questions have been answered and no responses are missing from any schedule or questionnaire. 2. Detect errors early, identify mistakes, contradictions, or unclear entries before they affect the coding or analysis stage. 3. Maintain data quality, ensures only accurate and reliable data moves forward into the processing stages. 4. Enable corrections, allows the researcher to go back to respondents and collect missing or incorrect data in time. Aspects checked. 1. Legibility, whether handwriting or entries are clear and readable for the coder. 2. Completeness, whether every item has a response and no question has been left blank. 3. Consistency, whether answers on different questions do not contradict each other logically. 4. Accuracy, whether responses appear factually correct and free from obvious errors or exaggerations. Editing, meaning. Editing is the process of carefully examining collected data to check for completeness, consistency, accuracy, and legibility before coding and analysis begins. The word editing means reviewing and correcting. It comes from the idea of preparing raw information, so it is ready for proper use. In research, editing is done on each filled questionnaire or schedule. The researcher looks for missing answers, unclear entries, inconsistent responses, and obvious errors. These are either corrected or marked as unusable before the data is coded. For example, if a respondent's age is written as 250 years or a question is left blank, the editor either corrects it by going back to the source or removes that entry from the dataset. Editing types. 1. Field editing done immediately in the field after each interview while details are still fresh, so errors can be corrected at once. 2. Central editing done at a central location after all data is collected. One editor reviews everything for uniformity. 3. Preliminary editing, a first-pass review to remove obviously incorrect or incomplete responses before deeper checking. 4. Final editing, a thorough last review of all data before coding begins, ensuring everything is accurate and complete. 5. Manual editing, reviewing physical questionnaire forms by hand to find and correct errors one by one. 6. Computer editing, using software to automatically detect out-of-range values, missing data, and logical inconsistencies. Editing, merits and demerits. Merits. 1. Improves data quality, removing errors and filling gaps ensures only clean, reliable data moves to the analysis stage. 2. Ensures completeness. All missing responses are identified early so the researcher can fill them before analysis. 3. Reduces analysis errors. Correcting data before coding prevents wrong conclusions from being drawn during analysis. 4. Increases consistency. Ensures similar responses are recorded in a uniform way across all questionnaires. 5. Builds researcher confidence. Knowing data has been edited gives the researcher confidence in the accuracy of final results. Editing, merits and demerits. Demerits. 1. Time-consuming. Reviewing each form carefully takes a lot of time, especially for large data sets. 2. Risk of editor bias. The editor may unconsciously change responses based on personal assumptions. 3. Loss of data. Incomplete or unclear responses may be discarded, reducing the total usable sample. 4. Subjective judgment. Different editors may handle the same error differently, creating inconsistency. 5. Costly if done manually. Manual editing of large-scale surveys requires many trained personnel and significant resources. Coding, meaning, time and levels. Meaning, coding is the process of assigning numerical or alphabetical codes to responses so that data can be classified, grouped, and processed systematically. When is coding done? It can be done before data collection, pre-coding, for structured questions, or after collection, post-coding, for open-ended responses. Levels of coding. Level 1. First-order coding. Initial identification and labeling of key concepts, terms, or patterns directly from the raw data. Level 2. Second-order coding. Grouping similar first-order codes into broader categories or themes for easier analysis. Level 3. Third-order coding. Organizing categories into higher-level theoretical concepts or final themes for interpretation. Coding, purpose, merits, and demerits. Purpose. To simplify and classify data so it can be easily entered into a computer or tabulated for statistical analysis. Merits. 1. Simplifies data, converts complex or lengthy responses into short codes, making analysis faster and easier. 2. Enables quantification. Qualitative responses are turned into numbers that can be counted, compared, and statistically analyzed. 3. Easy computer processing. Coded data can be directly entered into software for quick processing and analysis. Coding, purpose, merits, and demerits. Demerits. 1. Loss of meaning. Assigning a code to a response may cause loss of the original detail and nuance in the answer. 2. Coding errors. Wrong code assignment leads to incorrect analysis and misleading results. 3. Requires clear code manual. A detailed codebook must be prepared and followed consistently to avoid confusion. Transcription, purpose, merits, and demerits. Purpose. Transcription means transferring coded data from original questionnaires or schedules onto a data sheet, spreadsheet, or computer database for organized storage and processing. Merits. 1. Centralizes data. All data is moved to one place, making it much easier to manage, retrieve, and analyze. 2. Ready for computer analysis. Once transcribed to software, data can be sorted, filtered, and analyzed using statistical tools. 3. Easy to store and share. Digital transcription allows the data to be stored safely and shared with research team members. Transcription, purpose, merits, and demerits. Demerits. 1. Risk of transcription errors. Mistakes made while transferring data can silently corrupt the final results. 2. Time-consuming. Manually entering large amounts of coded data takes considerable time and effort. 3. Requires trained staff. Personnel must understand the coding scheme to correctly transfer data without mistakes. Tabulation, meaning and features. Meaning. Tabulation is the process of arranging classified data into rows and columns in a table to show frequencies, relationships, and patterns clearly. 1. Organized presentation data is arranged in a neat table structure that is easy to read and understand at a glance. 2. Saves space. Large amounts of data can be presented compactly in one table instead of long paragraphs. 3. Enables comparison. Data from different groups, time periods, or categories is placed side by side for easy comparison. 4. Facilitates analysis. Tabulated data is the starting point for applying statistical tools like averages, percentages, and correlation. 5. Shows patterns, trends, and relationships between variables become clearly visible when data is arranged in a table. Tabulation. Merits and demerits. Merits. 1. Simplifies complex data, converts raw, unorganized data into a structured form that is easy to read and interpret. 2. Supports comparison. Different data sets placed in the same table allow quick and accurate comparisons. 3. Foundation for graphs. Tabulated data is needed to create bar graphs, pie charts, and other visual representations. 4. Time-saving. Readers can find specific information quickly without reading through pages of text. Tabulation. Merits and demerits. Demerits. 1. Cannot show trends visually. Unlike graphs, tables do not give an immediate visual picture of trends or patterns. 2. Limited detail. Tables show numbers but cannot explain the reasons behind the data or its context. 3. Risk of misinterpretation. A poorly designed table with wrong headings or missing units can mislead readers easily. Essential parts of a table, parts 1 to 4. Part 1. Table number. Each table is assigned a serial number so it can be easily identified and referenced in the research report. Part 2. Title. A clear and descriptive heading placed at the top of the table that tells the reader exactly what the data represents. Part 3. Caption. Column headings, labels placed at the top of each column that describe the type of data contained in that column. Part 4. Stub. Row headings, labels placed in the first column on the left side that describe the categories or items listed in each row. Essential parts of a table, parts 5 to 8. Part 5. Body. The main section of the table that contains all the actual numerical data arranged in cells formed by rows and columns. Part 6. Head note. A brief statement placed just below the title that provides additional information like units of measurement used in the table. Part 7. Footnote. Explanatory notes placed at the bottom of the table to clarify specific entries, symbols, or special values used in the data. Part 8. Source. A note at the very bottom indicating where the data was collected from, essential for credibility and verification. Types of tabulation. 1. Simple tabulation. One way. Data is classified based on only one variable or characteristic. Gives basic frequency counts for a single factor. 2. Double tabulation. 2A. Data is cross-classified using two variables simultaneously. Shows the relationship between two characteristics in one table. 3. Complex tabulation. Manifold. Data is classified on the basis of three or more variables at the same time. Used for multidimensional analysis of complex data. Graphical representation. Meaning and features. Meaning. Graphical representation is the method of presenting data in the form of diagrams, charts, or graphs so that patterns and relationships can be seen visually. 1. Visual clarity. Converts numbers into pictures, making trends and patterns instantly clear to any reader. 2. Easy comparison. Different data sets can be compared visually in one graph without reading long tables. 3. Saves time. A single well-made graph communicates what many paragraphs of text would take long to explain. 4. Universally understandable. Graphs can be understood by people regardless of language barriers or technical background. 5. Highlights key data. Important values, highest points, and outliers are immediately visible in a graph. 6. Attracts attention. Visual displays engage readers more effectively than plain numbers or text-based tables. Types of graphs. Overview. 1. Bar graph. Uses horizontal or vertical rectangular bars to compare data across different categories. 2. Histogram. Displays the frequency distribution of continuous data using adjacent bars with no gaps between them. 3. Pie chart. A circular chart divided into slices to show how a total is divided into proportional parts. 4. Line graph. shows trends and changes in data over a period of time using connected data points. 5. Pictogram uses pictures or symbols to represent data quantities in a simple and visually appealing way. 6. Scatter diagram plots individual data points to show the relationship or correlation between two variables. Bar graph and histogram. Bar graph. 1. Easy comparison. Different categories are placed side by side, making it simple to compare values at a glance. 2. Simple to construct. Does not require advanced knowledge. Easy to create and read for any audience. 3. Not for continuous data, only suitable for discrete or categorical data, cannot represent continuous distributions. Histogram. 1. Shows frequency distribution, effectively displays how data is spread across intervals, showing concentration and spread. 2. Reveals patterns, normal distributions, skewed data, and outliers are clearly visible in histogram shape. 3. Difficult to compare groups, cannot easily display multiple data sets in one histogram without confusion. Pie chart and line graph. Pie chart. 1. Shows proportions clearly. Each slice visually shows what percentage of the total each category represents. 2. Visually appealing, colorful, and easy for audiences to understand without any technical knowledge. 3. Hard to compare similar values. When slices are close in size, it is difficult to tell which one is larger accurately. Line graph. 1. Best for showing trends. Connected data points clearly show increases, decreases, and patterns over time. 2. Multiple lines possible. Several data sets can be shown on one graph using different colored lines for comparison. 3. Not for discrete categories. Connecting unrelated categories with a line can be misleading and misrepresent the data. Pictogram and scatter diagram. Pictogram. 1. Visually engaging. Pictures or icons make data fun and immediately understandable even for non-technical audiences. 2. Good for public presentations, widely used in newspapers, infographics, and posters to communicate data to general readers. 3. Cannot show exact values. Symbols represent rounded values and cannot accurately show precise data figures. Scatter diagram. 1. Shows correlation clearly. The direction and strength of the relationship between two variables is visually obvious. 2. Identifies outliers. Data points that fall far from the pattern are immediately visible on the scatter plot. 3. Does not show cause. A scatter diagram can show a relationship exists, but it cannot prove that one variable causes the other. Thank you. Skill development questions in Chapter 5. Subscribe to Ria's notes for more. Bell. B.com BBA BCU.